Welcome to today's deep dive. And we are starting with a premise that sounds completely absurd at first, but is actually a fundamental fact of physics.
Right. It's one of those things that really messes with your intuition.
Totally. So I want you to picture something. Imagine you are riding on a high-speed train.
Okay.
You're looking out the window, watching the blur of the landscape pass by, and then you casually glance down at your own shoes.
Just a totally normal thing to do.
Exactly. It feels totally normal. You feel like you are seeing your shoes right now, in the present moment, on your feet.
But you aren't.
No, you aren't.
Yeah.
Because you are moving forward and light takes time to travel from your shoes to your eyes, you're actually seeing shoes from the past.
Right.
And not just shoes from the past, but shoes that were physically located in a space behind where you currently are.
It is a really profound realization when you stop and just think about it for a second. It completely upends our everyday assumption that we're all sharing the exact same instantly accessible now.
Yeah, we just take it as a given.
We walk around taking our perception of the present completely for granted. But the source material we are examining today forces us to confront a very weird reality.
What is that reality?
That everything you see around you at this exact second is entirely woven from different fragments of the past. These fragments are arriving at your eyes at slightly different times, and when you add your own physical motion into the mix, that incoming information gets completely distorted.
And the mission of this deep dive is to unpack exactly how that distortion works. We are venturing into a highly visual, really fascinating Japanese physics blog by an author who goes by EMA117Radio.
Yes.
The specific post we're looking at is titled Draft, Einstein Slacking Off 117.
It's quite a title.
It is. And it's just this treasure trove of radical thought experiments dealing with relativity, light speed delay, and this really slippery concept of simultaneity.
Absolutely.
But don't worry, we are going to translate the author's intricate 3D coordinate models into a theater of the mind just for you. No chalkboard math required.
Which is an excellent approach, I think, because the visual models provided by the author really do bridge that gap between abstract physics and human intuition.
They really do.
By rendering these concepts in 3D space, using software like Blender, the author provides a tangible map of how light actually behaves when the observer is in motion.
Right.
Though, as we will discover shortly, the entire point of this text is that even our best spatial maps have severe limitations when dealing with the true nature of time.
Okay, let's unpack this with the very first thought experiment from the blog. The author introduces a character called the manager, or bucho in Japanese.
Wucho.
Right. I want you to imagine the manager as a person sitting right at the central point of a half mirror. And the manager isn't sitting still. They're moving along a straight line.
The x-axis.
Yeah, let's call it the x-axis. And they're moving at 60% the speed of light. We'll refer to that as 0.6c.
Okay, so to help us visualize what happens next, the author provides a series of specific 3D models created in that Blender software.
Right, the 3D grid.
Exactly. In this digital environment, imagine a flat, horizontal spatial plane. It's an XY grid, essentially a vast, flat floor.
Okay, I'm picturing a floor.
But then there's a vertical axis shooting straight up from the floor. That vertical axis, the z-axis, doesn't represent height or physical depth.
This is the mind-bending part.
It represents time.
Wow.
It's denoted in the text as z. So as you move higher up that vertical pole, you are moving forward in time.
Okay, so we have our stage set in this 3D space. The flat floor is space. The vertical pole is time.
Right.
The author then describes 360 individual atoms arranged in a perfect circle around our moving manager at a radius distance of 10 units. Imagine a giant ring with the manager in the dead center.
Okay.
The goal of this experiment is for all 360 atoms to fire a tiny laser beam, a light ray, so that every single ray hits the moving manager at the exact same moment.
In the 3D model, this simultaneous arrival moment is represented by a green line.
A green line.
Right, essentially marking the absolute now for the manager at time 0.
So they all hit at time 0.
But zooming out from the 3D model for a second, what this actually tells us about the universe is incredibly strange.
Yeah.
We have to map the paths of those light rays backward through both space and time to see exactly when and where they had to be fired.
Because the manager is moving.
Exactly. Think about the manager's situation. They are rushing forward at 60% the speed of light.
Right.
That means they are constantly running away from the light emitted by the atoms behind them.
And they are rapidly rushing toward the light emitted by the atoms in front of them.
Precisely.
Meaning the light coming from behind has to cover way more ground just to catch up.
Yes, for the light from the back of the circle to reach the manager at the exact same time as the light from the front, that atom at the back had to fire its light ray much earlier in time.
So the timing isn't uniform.
Not at all. The timing has to be staggered perfectly across the entire circle.
And this leads to an amazing visual aha moment in the blog.
It really does.
When you plot the origins of these light rays in that 3D space where the vertical axis is time, they don't form a flat circle on the floor anymore.
No.
They form what the author calls a skirt shape. It looks like a cone, or the flared skirt of a dress, angling downward into the past.
A temporal skirt.
Yeah. In the author's screenshots, you see these red rings dipping way down the time axis to T25 or T40.
And those red circles represent where the light started in the deep past.
Exactly. To hit the manager simultaneously at that green line of now, the light rays literally have to travel up the slanted fabric of this temporal skirt.
What's fascinating here is that it forces us to realize your brain is essentially acting as a heavily delayed video rendering engine.
A rendering engine.
Yes.
Yeah.
You aren't seeing an objective reality. You're seeing a highly edited broadcast.
Wow.
To experience a simultaneous now at a single point, for the manager to see that ring of light arrive all at once, the universe has to coordinate events across vast, unequal distances of space and time.
But it feels like a single moment.
What the manager perceives as a single, simultaneous flash of a circle is actually a chaotic compilation of countless different pasts, all carefully arranged on that sloping skirt of time.
That is wild to think about. It really means that whenever we feel like we are experiencing a clean, cohesive moment, the universe is doing an enormous amount of background editing to make that happen.
A staggering amount of editing.
But if our perception of now is just a stitched-together composite of different pasts, what does that do to the physical shapes of things around us as we move?
That is the million-dollar question.
And the blog introduces another character to tackle this exact question. Enter the Train King.
The Train King.
Yeah. The Train King is also cruising along that same x-axis at point 6C, and the Train King is observing a physical object this time. He's watching a train that has a total length of 20 units.
And this is where the author brings in a historical astronomical concept to explain the visual distortion the Train King experiences.
Right, the Bradley thing.
Yes, the text cites Bradley's stellar aberration.
Stellar aberration.
This was originally discovered by the astronomer James Bradley in the 1700s when he was trying to measure the parallax of stars.
Okay.
Bradley realized that because the Earth is moving through space, the angle that starlight appears to arrive from is fundamentally altered. It is an optical illusion created purely by the observer's own velocity.
The author uses an analogy for this called deviation shooting, which comes from gunnery, where you have to aim ahead of a moving target.
Right.
But here, the light itself is doing the deviation. Let's look at the front tip of that train the Train King is watching. If the Train King and the train were both sitting perfectly still, light from the tip of the train might hit his eye at a nice, predictable 45-degree angle.
But they aren't sitting still.
Right. Because the Train King is moving forward so incredibly fast, he is essentially driving his eyes into the incoming photons.
That forward momentum causes the light from the tip of the train to hit the observer at a much sharper, narrower angle.
So it looks totally different.
It completely changes the apparent position of the object in your field of vision. A helpful way to visualize this in everyday terms is to think about driving a car in a rainstorm.
Oh, this is a great analogy.
Imagine the rain is falling perfectly straight down from the sky. When you're stopped at a red light, you look out your side window and you see the rain falling vertically.
Straight down.
But the moment the light turns green and you hit the gas, the perspective shifts.
The rain suddenly looks like it is slanting directly toward your windshield.
Yeah.
And the faster you drive on the highway, the more horizontal the rain appears to be coming at you.
Exactly. The actual path of the rain hasn't changed at all. Your forward motion is simply changing your relative angle of interception.
That makes perfect sense.
And the author of the blog is applying this exact logic to the fundamental speed of light. Because the Train King is moving at 0.6c, every single photon of light entering his eye is like a raindrop that appears severely slanted by his own speed.
Which brings us to a specific scenario the author calls the 0.8c illusion.
This one is really counterintuitive.
It really is.
Yeah.
So the Train King is looking down at the track directly beneath him. Now, light bouncing off the floor of the train right underneath him expands outward as a spherical wave.
Right.
My immediate intuition here is that as he moves forward at 0.6c, the light coming from directly below should look like it's trailing behind him.
Because he's moving past it.
Exactly. He's leaving that physical spot on the track behind, so the light should appear to come from behind him.
You would intuitively think so, but the geometry of relativity creates a fascinating illusion.
How so?
Think about dropping a tennis ball out of your car window while driving down the highway.
Okay.
To someone standing still on the sidewalk, the ball moves forward with the momentum of the car while also falling down, creating a long, curved trajectory.
Right, like a parabola.
But to you, sitting in the driver's seat, the ball just looks like it is falling straight down relative to your window. Your own forward speed entirely hides the horizontal travel of the ball from your perspective.
Wait, let me make sure I'm picturing this correctly with the light.
Go ahead.
So because the train king is moving, the light that actually originated from a spot slightly behind him essentially catches up to his eye at an angle that tricks his brain into thinking it came from straight below.
That is exactly the mechanic at play. The light is traveling outward in all directions at the speed of light, which we'll call 1.0 c.
And the train king is moving at 0.6 c.
Right. So the specific photon that manages to successfully intercept the train king's eye as he moves forward does so in a way that perfectly masks its horizontal journey.
Incredible.
To the moving train king, the spherical wave of light appearing from the floor doesn't look like it's falling behind at all. It seems to shoot straight up at him from the floor at an apparent spatial speed of 0.8 c.
So his forward motion completely hides the fact that the light originated behind his current position.
Yes.
The illusion is flawless,
Oh.
and he has absolutely no way of knowing, just by looking, that the floor he sees directly beneath him is actually a light image of a place he has already passed.
It is an inescapable optical illusion generated by the mechanics of the universe itself. And it perfectly illustrates why the author feels that our standard ways of mapping reality are so insufficient. We keep trying to force these relativistic effects into standard static 3D boxes.
We want things to be simple.
We try to use an X, Y, Z coordinate system that treats space as an absolute grid and time as just a ticking clock running quietly in the background. But as the train king's distorted vision shows us, the physical space you perceive is heavily dependent on your interaction with time and motion.
So if our forward motion is constantly warping the angles of everything we see, and our now is just a skirt-shaped collection of old light, how are we supposed to accurately map where anything actually is?
That is the core problem.
Here is where it gets really interesting. The blog post makes a massive intellectual leap. The author suggests we shouldn't even try using traditional space.
Right.
They propose completely abandoning standard 3D physical maps, those Cartesian coordinates we all learned in school. Instead, they propose shifting the axis.
A fundamental shift.
What if, instead of the axis representing spatial depth, like how many feet away a wall is, we make the axis represent time?
This is a highly sophisticated intellectual maneuver. And to build this argument, the author references Galileo's concept of pendulum isochronism.
Pendulum isochronism.
Yes. The famous story goes that Galileo was watching a chandelier swing back and forth in a cathedral.
Okay.
He noticed that whether the chandelier was swinging in a wide arc or a very narrow arc as it slowed down, the time it took to complete one full swing was exactly the same.
Oh, I see. So the spatial distance of the swing changed, but the temporal duration remained perfectly constant.
Exactly. It's a principle of finding equal time intervals regardless of the physical space covered.
That's brilliant.
The author then connects this constancy of time to a modern theoretical concept by Dr. Akifumi Higashi called the dense clock field.
Dense clock field. It's a great phrase. What exactly does Dr. Higashi's concept mean in the context of mapping the universe?
Imagine that every single microscopic point in the universe, every coordinate in space, has its own invisible, perfectly synchronized clock.
Okay, a clock at every point.
A dense clock field suggests a reality densely packed with infinite temporal markers. The author uses this idea to propose restructuring how we map reality entirely.
So abandoning distance.
Instead of mapping objects by where they physically sit in space, which we know is an illusion distorted by our movement, we should group them by their temporal distance from the observer.
So we treat time as the primary geographic feature.
Yes.
The author wants to take a group of points that we visually perceive at the same moment and sort them by how long the light took to reach us. Let's try to visualize this in a room.
Go for it.
If I look around a studio, instead of mapping the microphone as being 2 feet away and the soundproof door as being 10 feet away, I would ignore those spatial distances.
Entirely.
I would create a unified layer of reality that consists only of events that happened exactly 3 nanoseconds ago.
Yes, and doing so creates what the author terms a complex space.
Complex space.
In this complex space, your primary coordinate isn't where, it is when.
Wow.
You are mapping the universe based strictly on the delay of information. You are taking a standard visual image and deconstructing it into concentric shells of time.
Like an onion.
Exactly like an onion. You are peeling back reality layer by temporal layer.
The author grounds this incredibly abstract theory with a fantastic everyday reference that I think most people will recognize.
The sun.
Yes, the 8 minutes ago sun and the gap with reality. We learned pretty early on in science class that light from the sun takes about 8 minutes to reach Earth.
It is the perfect anchor for this whole concept.
Because it's so relatable.
When you look up at the sky and see the sun, you are not seeing the sun as it physically exists in that exact moment. You are looking at an 8-minute-old ghost.
An 8-minute-old ghost.
The physical matter of the sun has already moved on. It has spent the last 8 minutes rotating, burning, and traveling millions of miles through the galaxy along with the rest of the solar system.
But we still point at the sky and say, there's the sun.
The image you see is just a delayed postcard arriving long after the sender has left the building.
And what the author is saying is, take that 8-minute gap, that ghost effect, and apply it to every single object in your immediate surroundings.
Right.
The gap isn't 8 minutes for the coffee cup sitting on your desk. It might be a tiny fraction of a nanosecond. But the gap is still fundamentally there. The coffee cup you see is a ghost, too.
A very recent ghost, but a ghost nonetheless.
And when you move, your motion bends those incoming ghost signals, altering their angles, just like the train king experiencing the slanted rain.
And forcing the light to travel up a temporal skirt, just like the manager.
It is a brilliant synthesis of scale. We easily accept the light delay for stars and planets because the distances are so vast that the delay becomes obvious to us.
Right, astronomy forces us to accept it.
But we completely ignore it in our living rooms because the delay is imperceptible to our slow biological senses.
Physics, however, doesn't care about our biological limits.
No, it doesn't.
The rules of light speed delay and the distortion of moving observers are happening right in front of us at every scale, constantly weaving together a tapestry of different pasts and presenting it to us as a cohesive, seamless now.
So what does this all mean? Let's bring all of this together. Our brains are basically the ultimate illusionists.
They really are.
They trick us into thinking we live in a neat, tidy 3D box of right now. We think the world is exactly as it appears, stationary and absolute.
But physics proves our intuition is totally wrong.
Completely wrong. As mapped out by the author's intricate blender models of the manager's skirt of time and the warped visual angles of the moving train king, we actually live at the collision point of countless different pasts.
And the shape of that collision is entirely dictated by how fast we happen to be moving through space.
So what's the big takeaway for you from all these sources?
I think the most crucial takeaway here is a famous philosophical phrase that the author's work embodies. The map is not the territory.
I love that phrase.
We have invented Cartesian coordinate systems, rigid X, Y, and Z grids, to make sense of the world, to build buildings and navigate cities.
It's practical.
Very practical. But that standard map fundamentally fails to capture the bizarre truth of light speed delay and relativity.
It just doesn't account for time as a geometry.
Right. If we want to understand the true structure of reality, we have to look past the intuitive map and realize that space and time are inextricably linked. Our perception is just a highly edited broadcast of delayed information, and standard geometry simply isn't equipped to tell the whole truth.
It really leaves you looking at the world and everyone in it differently. I want to leave you, the listener, with one final provocative thought to mull over today.
Let's hear it.
Think about everything we've unpacked today. The sloping skirts of time, the altered angles of the moving train king, mapping the room using a dense clock field. If our entire perception of reality is completely constructed from delayed fragments of the past, and those fragments are bent and distorted by our own specific motion through space, then is your present ever truly the same as the present of the person sitting right next to you?
That is a fascinating thought. Even if they are just a few inches away, their exact position and micro-movements mean they are receiving a slightly different compilation of past light.
Yes. The angles are different.
The delays are different.
Exactly. Which begs the question, are any of us actually sharing a now Or are we all entirely isolated, floating inside our own custom-built temporal illusions?
It's a beautiful, isolating, and undeniable fact of physics.
It really is. Well, thank you so much for joining us on this deep dive into the warped, wonderful world of light speed delay and relativistic observation. Keep questioning the map, keep looking closely at the territory, and we will catch you next time as we plunge into another incredible stack of sources. Stay curious.